Question 3, we have matrix multiplication. Now, matrices are multiplied as across and down. So for example, if you have like 1, 2, 3, 4, 5, 6, 7, 8, you do 1 times 5, 2 times 7, and add them up, which is 5 and 7, 14, 19 goes here. And then this times this, 1 times 6, 2 times 8, 16 plus 6, 22. This times this, 3 times 5, 15, 28, and 43, and then 3 times 6, 4 times 8, 32, 18, so it's 50. Yeah. So that's how you multiply matrices. When you have a matrix, the number of rows and number of columns are counted to give you the dimension of a matrix. So for example, if I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, and 12. Let's say you have this matrix. This has 1, 2, 3, 4, no, 1, 2, 3, 3 rows, and 1, 2, 3, 4, 4 columns. So it's a 3 by 4 matrix. And because the matrix multiplication goes by across down, the number of elements as you go across should match with the number of elements as you go down. This means the number of columns should match with the number of rows. Okay, so what does that mean? That means if you have a m by n matrix and you multiply it to another something by k matrix, then this number has to match with this number. So only when these two numbers are same, if this is n, this should also be n, then you end up with a matrix that's a m by k matrix. Okay, that can tell you whether a matrix operation with multiplication is defined or not. So here, look, this is a 2 by 1 matrix because it has 2 rows and 1 column. This is a 2 by 2 matrix, and as you can see here, this number and this number doesn't match, and because that doesn't match, this is undefined. Whereas this one, this is a 2 by 2 matrix, and this is a 2 by 1 matrix. In this case, these two do match, and therefore you're going to get a 2 by 1 matrix. 2 by 1 matrix as an outcome. So let's try that. Use a different color. This times this. So you have 3 times 3 plus -1 times -2, which is 2. So it's 9 plus 2, that's 11. And then you do across and down. Then 5 times 3 is 15. 1 times -2 is -2. 15 plus -2 is 13. And therefore, the matrix that you get is 11 and 13. Okay. However, when it comes to addition of matrices, you need the same exact dimension. When you add or subtract matrices, you're supposed to have same exact dimension. So for example, here you do 2 by 2 and 2 by 2 so that these two can be added or subtracted. And the way you add or subtract this is simply element-wise. So 3 minus 3 is 0. -1 minus -1 is 0. 5 minus -2 is 7. 1 minus 1 is 0. So that's the result of this difference. However, here, because this is a 2 by 1 matrix and this is a 2 by 2 matrix, you're not allowed to add such matrices. So this is again undefined. Alright, this last question requires you to do a matrix inversion. So let's talk about formula for matrix inversion. So the formula for matrix inversion is if you have a 2 by 2 matrix, this formula is just for 2 by 2 matrices. If you take the inverse of a 2 by 2 matrix, that's supposed to be 1 over the determinant, and then you do A and D should be switched, and then B and C should be negated. Okay. In other words, diagonals should be switched. The off diagonals should be negated. Let's see how that applies to our question here. So if you have 3, 2, 2, 1, negative 1, first you have to compute the determinant. Let's see, what's the determinant? 3 times 1 minus 3 times 1 minus, somebody, where's this? 3 times 1 minus 2 times 2, which is 3 minus 4, and that's negative 1. Okay. So you do 1 over negative 1, and then 3 and 1 should be switched, and 2 and 2 should be negated. And finally, if you multiply, this is negative 1. If you multiply negative 1 to this matrix, it's negative 1, positive 2, positive 2, negative 3. So that's the matrix that you get for the inverse. Therefore, this is now equal to negative 1, 2, 2, negative 3, multiplied to 1, negative 2. And then we, again, do across down, which means negative 1 times 1, which is negative 1. 2 times negative 2, that's negative 4. Negative 1 plus negative 4 is negative 5. Then you do across down. 2 times 1 is 2. Negative 3 times negative 2 is 6. 6 plus 2 is 8. Okay. And that's the answer for this product. Okay. Number 4, we have the following system of equations. And first it says, write this in matrix form. When you have an equation that's of form ax plus by equals to c and dx plus ey equals to f, this type of equation can be written as a, b, c, d times x, y equals to c, f. Now the reason these two are the same is easy to see if you just do the multiplication. If you do across down, a times x plus b times y is what you get on the top, right? So you get ax plus by. If you do across down on here, then you get cx times dy, which is cx plus dy. And we're trying to say that this matrix is equal to the matrix on the right side, which is CF. And as you can see, AX plus BY is C and CX plus DY is F. Exactly the same thing as this. Okay? Now, sometimes you might be given an equation not of this form. You might have something like 3x equals to 1 minus 2y instead of this. In that case, you have to bring all the variables on the left side, so you get x and y on the left side and the constants on the right side. Only then you can write it into this form. Okay, so in our example, the matrix form will be 3, 2, 2, 1. That's the coefficients of x and y. So put that as a matrix. Put x and y. And then you put 1 and negative 2. Now, if you put this into matrix form, then you can figure out what x and y are by dividing this to the other side. And maybe I should try to rewrite this again. So here's what we're trying to do. If I have 3, 2, 2, 1 xy equals to 1, negative 2, then we should multiply 3, 2, 2, 1's negative, 3, 2, 2, 1's inverse matrix. This is an inverse matrix. And the result of this calculation, if you multiply an inverse matrix to itself, they just cancel away, leaving you with x and y being this matrix. Now, I purposely made this matrix to look like exactly what we did in the previous one. So let's take a peek. This is the same exact calculation as the previous question's E, and its result was, as you can see, it's negative 5 and 8. So now we can say it's negative 5 and 8. Okay, negative 5 and 8, right? Okay, so that means x is negative 5 and y is 8. That's how you solve a system of equations using matrices. Compute the following. First of all, this bar on top, that's called a conjugate. If you have a plus bi, and if you put a bar over it, that's same as a minus bi. Okay. So let's first try to figure out what 3 plus 2i divided by 1 plus i is. Okay, so let's try to calculate that. 3 plus 2i divided by bar of 1 plus I. That's 3 plus 2i divided by 1 minus I. The way you perform division of complex numbers is by multiplying the conjugate top and bottom. Okay. Multiply the conjugate. So top one is the same, but I'm going to multiply 1 minus to 1 minus I. I'm going to multiply 1 plus I, and I want to do the same to the top. 1 plus I. 1 plus I. Now you multiply complex numbers just as you would multiply polynomials. So use FOIL. 3 times 1 is 3. 3 times I is 3i. 2i times 1 is 2i. And 2i times I is 2i squared. You do the same in the bottom. 1 times 1 is 1. 1 times I is I. Negative I times 1 is negative I. Negative I times plus I is minus I squared. And then you combine the like terms, but before you do that, I squared is negative 1. That's probably the only difference between expanding a polynomial and expanding a complex number. You just have to replace I squared by negative 1. So negative 1 times 2 is negative 2. 3 minus 2 is 1. So that's what you get for the real part. 3i plus 2i is 5i. Whereas on the bottom you have I minus I. These two cancel. And I squared is negative 1. Minus negative is plus 1. So 1 plus 1, that's 2. So that's what you get for this part. Then you just have to combine the like terms and that's it. Okay, so 4 plus 5i minus 1 plus 5i over 2. Let's make common denominators. So make everything over 2. Is 8 plus 10i minus 1 minus 5i. Be careful, this minus affects both. And then if I collect the like terms, 8 minus 1 is 7. 10 minus 5 is 5. So 7 plus 5i divided by 2. That's the answer for this. When you have your complex number in terms of these polar form, this 2 is the magnitude and pi over 3 is the angle. You first have to change it to rectangular in order to add. When it comes to multiplication, you don't want to do that. So let me just make a remark that if you have a angle theta and times b angle phi, then when you multiply them, then it's AB as the new magnitude, length of the complex number, and theta plus phi as the angle. Actually, the correct terminology is A is called the modulus, and theta is called the argument. But it's just like vectors, so A is more like the size of that vector, and theta is the angle from the positive x-axis. That's what they mean. Proper naming is that this is called the modulus, and this is called the argument. Okay. So if it was a multiplication, then we can just simply do the calculation without having to worry about converting to rectangular. However, this is addition. That means we have to actually convert it to rectangular before we do any calculation. So let's see, what's the formula for doing that? If you have A angle theta, or I think you're more used to having R as R there. Okay, so this should be, let me rewrite this. Okay. So if you have length R and angle of angle theta, then this is R times cosine theta plus R times sine theta I. Okay, so that's the formula for converting polar form into a rectangular form. You probably remember this from the changing polar coordinates to rectangular coordinates. It's the same thing. Okay, so we have 2 times cosine pi over 3 plus 2 times sine pi over 3 I from the first number, and then plus we have 4 times cosine 2 pi over 3 plus 4 times sine 2 pi over 3. Okay, pi over 3 is 60 degrees, and 2 pi over 3 is, this is 2 pi over 3 is twice of pi over 3, so this is 120 degrees. And therefore, you need to know the cosine and sine values at these special angles. So please have them memorized, assuming that you do know. Let's see, cosine pi over 3 is 1/2, so it's 2 times 1/2 plus 2 times radical 3 over 2. And then cosine 2 pi over 3 is negative 1/2, whereas again, sine 2 pi over 3 is radical 3 over 2. Okay. Then, let's see, 2 times 1/2 is 1. 2 and 2 cancel, so it's radical 3i. And then 4 times negative 1/2 is negative 2. And then 2 radical 3i, that's what you get. And then if you combine the like terms, 1 minus 2 is negative 1. And radical 3 plus 2 radical 3 is plus 3 radical 3i. Okay, so that's what you get. Finally, let's try the last question. Now for this one, you need to use something called the Moivre's formula, which is that if a complex number is written in polar form, and if you take the nth power, that's same as a to the nth power angle of n times theta. This is due to that formula where if you have two numbers in polar form, the modulus gets multiplied and the angles gets added up, so theta plus theta is 2 theta. And if you just do this over and over again, you get this thing called de Moivre's formula. Okay, so if I apply it to here, I end up with 2 to the 8th power angle 8 times pi over 3 times e to the pi over 4i. Well, this you may recognize it as the Euler form. So what's the Euler form? Euler form is if you have a times e to the I theta, this is same as a angle theta. So you can rewrite, since this is like 1 times e to the pi over 4i, the second one can be written as 1 times angle pi over 4. 2 to the 8th is 256. And 8 pi over 3, let's see, 8 pi over 3, let's see. That's beyond 360 degrees. So if I subtract 2 pi to get the coterminal angle, that's 8 pi over 3 minus 6 pi over 3. 8 pi minus 6 pi, that's 2 pi over 3. Okay, so you have 2 pi over 3 from there. Then you do 1 sorry, I'm trying to erase. Okay, let me do this over again. Okay, so I have 2 pi over 3 computer is acting up just a minute. Okay, so it's 2 pi over 3 times 1 angle pi over 4. And then using this formula, when you multiply two complex numbers in polar form, the modulus multiply 256 times 256 times 1 is 256. And the angles add up, 2 pi over 3 plus pi over 4. They are on over 12, this is 8 pi over 12 plus 3 pi over 4. 8 plus 3 is 11, so you get 11 pi over 12. Yeah, so the final answer is 256, 11 pi over 12. Now find all solutions to the algebraic equation z cubed equals to 4 radical 3 minus 4i in Euler form. Now to do this question, you first have to figure out how to change the right side into the Euler form. So to recall, Euler form is if you have r e to the I theta, that's r angle theta. Okay? So in order to get the Euler form, you first need to put it as a polar form. In order to make polar form, you need to know what r is. R is square root of x squared plus y squared for x plus yi, so it's square root of 4 radical 3 squared plus negative 4 squared. Now, common mistake is a lot of people have a mistake of putting the I in here too. No, for x plus yi, you do not include the I, but you only put the y in here, and you compute this. Okay, if you compute this, you get 16 times 3, which is 48, plus negative 4 squared, which is positive 16. That's square root of 64. That's equal to 8. Okay. Do not include I in here. Okay. All right. Now you need to get the angle. How do you find the angle? Angle formula is a tangent inverse of y over x plus some alpha, where alpha is this modification in the case when you're in the second or third quadrant. See, tangent inverse produces angles between negative 90 degrees to positive 90 degrees. So if you're on the first quadrant or the fourth quadrant, you don't need to do anything. But if your angle happens to fall in the second quadrant, that's beyond 90 degrees. So the tangent inverse will give you a wrong answer, which is off by 180 degrees. Therefore, you have to add 180 degrees. And for the third quadrant, you have to subtract 180 degrees. Now, when things are done in Euler form, you're supposed to use radians. So therefore, in our case, we'll be using alpha as 0, 0, and then pi and negative pi. Okay, so let's try this. See, 4 radical 3 is positive, and negative 4i is, that's the negative y coordinate. So you're in the fourth quadrant for this one. So in that case, we don't have to add anything. Right? It's 4 radical 3 is positive. You go down by 4, negative 4, so you're in the fourth quadrant. Therefore, you don't need to add anything, and you just have to do tangent inverse of y, which is negative 4, x, which is 4 radical 3. 4, 4 cancels, so you get tangent inverse of negative 1 over radical 3. Okay. See, maybe I should have highlighted this. So you're in the fourth quadrant, so you don't have to add anything. So alpha is like 0. Okay, so coming back, tangent inverse of negative 1 over radical 3. If you have a minus, you can pull it outside the tangent inverse. By the way, this is only true for tangent inverse and and sine inverse. If you have cosine inverse, then you can't do that. All right, so now what do you have? Tangent inverse of 1 over radical 3 is, this is 30 degrees. And 30 degrees in radians is pi over 6. Okay, therefore, the answer we get is, the right side is at least, it's not the answer yet. The right side is 8 angle e to the negative pi over 6i. Okay, so that's like the first step. We've done the first step. Now the second step, what do you do? Now let's set z as my Euler form, e to the I theta. And then z to the third power would be, yeah, maybe I should write this again here. Okay, so if I set z as r e to the I theta, then z cubed will be r cubed e to the I theta cubed. But if you cube an exponent, the exponent multiplies, so you get r cubed e to the 3 theta I. And this is what I'm trying to equate with this 8 times e to the negative pi over 6i. So we have the following identity. We see that r cubed, which is the modulus of z cubed, has to equal to 8, and 3 theta, which is which is the argument of z cubed, has to equal to the argument of the right side, which is negative pi over 6. So angles have to match and their sizes have to match. Now sizes are always positive, so r is 2. That's just taking the cube root of 8, you get 2. So that's not a problem. However, this one is actually half true. It's not actually really true. If you have two complex numbers and they're equal, their angles may not be the same. Their angles might be coterminal angles. So if these two angles are not equal but still 2 pi apart, say negative pi over 6 plus 2 pi, as complex numbers they represent the same point on the complex plane, so they end up being the same complex number. So we can't really say for sure that 3 theta, just because you have 3 theta here, just because you have a 3 theta here, because you have 3 theta here and negative pi over 6 here, you can't say they're equal. You can only say that they are 2 pi apart. So it's either this or that, or still even more, negative pi over 6 plus 4 pi. Now you might wonder, well, how far do we go? When do we stop? Well, luckily we know that a cubic equation has at most three answers. So we stop when we get three different answers. Okay. What's going to happen is that if you go further, you're going to just repeat the same answer at the end of the day. Okay. So let's see, what does that mean? That means 3 theta is negative pi over 6, or 2 pi is, if you add, that's 12 pi over 6, so it's 11 pi over 6. And 4 times 6 is 24. 24 minus 1 is 23 pi over 6. And therefore, if you divide by 3, you get theta equals to negative pi over 18. 11 pi over 18. And 23 pi over 18. Okay? So those are the possible angles. Therefore, the answer is the following. Answer is 2 times e to the negative pi over 18i. Or 2 times e to the 11 pi over 18i, or 2 times e to the 23 pi over 18i. So that's the answer.